Good morning, everybody. How are you today? I hope everybody had a wonderful weekend. All right, we're going to talk about some things called surface tension today. And I have some water, and this is a clear plate. I'm going to save that for a different experiment just because you can see through it. And these are things that you can do at home. All of these today are things you can do at home. And what I'm going to do is I'm going to take some pepper. I'm going to sprinkle pepper all over my plate. All right. So now I have a Q-tip. I'm going to take, all right, Mrs. C, do we have the top view on for this one yet? I have the Q-tip, and I'm going to put it down into my plate and see what happens. The pepper actually tries to stick to my Q-tip. It really doesn't do much at all, does it? So what we're going to do now is I'm going to take just a dab of dish soap, and I'm just going to put it down in the center just like I had it. That is so awesome, isn't it? Look at that. That is so cool. And you're like, what just happened? So today we're going to be talking and exploring surface tension. It's a really cool phenomena. And basically what happens is you have water, and water molecules are attracted to each other, right? They want to be stuck together, and that force, surface tension, helps them stick together. Now the top molecule, so there's water, there's layers of water molecules. The bottom molecule is sticking to the one above it and to the ones all around it. And what I want to do really quick, I'll draw it out. Can we see this? Woo! I need to move that. So here we have our water, and this is going to be the top here. And I'm just going to draw a couple of water molecules. And these molecules want to stick to each other, right? They have a force. This one's moving over here, this one's moving here. And basically they're going in all these different directions. But the ones on top, the ones that are sitting on top, don't have the ability to stick to water molecules in each of the directions. They only can stick to the water molecules next to them. And because of that, they have a greater tendency to want to stick to those. Now I know that drawing is just absolutely beautiful, but these up here, these water molecules create a force that keeps them stuck together more. In order for us to break that bond, we use a little bit of dish soap. It helps break that bond, and then we can see where the bond is broken because all of the pepper and everything moves away from it. All right, so I have this little pan over here. I'm gonna just dump this out. And I'm gonna have a whole stack of plates because once we use one of the plates, we won't be able to use it again because there's soap on it. So let's try that one again. That one is super cool. And last time we put it right in the center. I'm just gonna kind of do it off center a little bit. I'm excited to see you guys do this at home too. And right now you can see that the water is moving, right? You can see the water is moving. And the pepper allows us to see that. We're just going to give it a second to slow down and calm down. And eventually it'll get still.
I vote for more pepper.
More pepper?
Make it spicy.
Let's spice up this experiment. Some of the pepper's actually falling down. I can see it hitting. I can see hitting the plate. I love the smell of pepper. It's the best. But it's floating on top because of surface tension. So the pepper is floating on top of the water because of surface tension. And have you ever heard of like water striders? They look like the spiders that run across the water, and they stand on the water and they can slide across it. And they can do that because of surface tension. All right, here we go. So just to prove, this is a Q-tip. Nothing's on it, but when I touch it, they kind of go towards the center. But now, a little bit of soap, and it's pretty cool what happens here. I know we've already done it, but... So it didn't move as fast, right? It didn't appear to move as fast, and that's because we had a lot more pepper.
So we have a question. Does this work with other spices?
Oh, does it work with other spices? I guess We could try that, or you could try it. Should we try it? We've got paprika.
Sure.
Let me grab some paprika. I'm going to dump this. That is going to be like a really gross thing here. Be right back. All right, so we have oregano. I almost said oregano. Oregano and paprika. So we'll give it a try. Let's try. I used this yesterday. I made schnitzel. That's German food. Yummy. All right, here we go.
So maybe salt.
Salt.
That would be hard to see. Or
Yeah.
cinnamon.
I don't know. We couldn't find our cinnamon the other day. Remember we were looking for that for something?
I think it all got used on toast.
Cinnamon toast. All right, here we go. I'm going to get this ready just so that all right, it's floating. That was my concern, whether it was going to float or not. Whoop. All right, here we go. 3, 2, 1. Yay, paprika works. Honestly, I thought the paprika was going to mix in the water and kind of float into it and kind of dissolve into it. Yeah, mix more easily. But that worked. I'm surprised. I did not think it was going to work. Whoever's idea that was. All right. We can try one more. We can do the oregano.
We have a teacher who said that they use this to talk about germs. How soap keeps the germs away.
Yeah, we were going to actually kind of touch. I love the smell of that. We were going to actually talk about how soap helps us with germs.
Ooh, and Francesco also said, would it work with 2 spices at once?
2 spices at once? That's crazy talk. All right, so let's try the oregano. All right, here we have oregano. Now, these are heavier than the pepper flakes and the paprika. I mean, I'm assuming, but here we go. 3, 2, 1. Oh, that was so cool. I was wrong. Look how fast they moved. That was so awesome. Look at that. Beautiful art. I wonder though, like if I put it over here, no. See, I broke the surface tension. I broke the surface tension here in the center, so those water molecules don't want to behave the same way now. All right, those are awesome. So Francesco, I challenge you to mix up the spices. Do something crazy. Not just Francesco, anybody out there watching. Try different spices mixing together. Pepper, paprika, oregano, cinnamon, someone suggested. And I'm going to put some water in here. But we didn't have the camera angle at a good angle when we did this. I just threw something on the floor. I'll need that later. But we were trying to see if we could get a paperclip to float. And we got it to float, but the camera was like here and we just couldn't see it. So we can see this now, right, Mrs. C?
Yeah.
Okay. I'm going to make it a color. Do you think that would help if I made it yellow to see the paperclip against it?
We're just going to zoom in a little bit. Maybe that'll help.
All right, I'm going to make it yellow anyway. All right. So what we have here is a paperclip. Ow, that hurt my elbow. And I'm going to just try to set it on top, but it sinks. So, I know what you've been thinking. How can we get this paperclip to actually float? And there are a couple of ways to do it. You can take another paperclip, a larger one, and make it like a cradle. Oh, that's my left hand. I don't have, my left hand isn't as steady. All right, I'm going to put this on here. Oh my gosh, I'm not going to have any paper clips left. Hold on, I'll just set it here and do it. I'm so nervous. All right, so I'm going to take this and I'm just going to lay it. And our paper clip is floating on the top of the water. And it's being held there by surface tension. So it'll stay there until we do something to it. What do you think we're going to try? Soap. We're going to actually take this and see if it'll break the surface tension the same way it did in the shallow water. All right, so I'm going to take a little dab of soap. All right, here's our paper clip. I'm just going to put this here. That was so cool. So it did. It broke the surface tension just like it did in the shallow water. Another cool experiment you can try with your friends. You can even trick and bet your friends that they can't get a paperclip to float in water, because everybody is going to just try to do it like this. Ooh, I wonder if the big one will float. All right, we're going to get some new water because I added soap to that one. Did the color help? No?
No, I don't think it did.
All right, we're going to try this big one.
Maybe.
All right, you want to put it in?
Sure, do a different color.
Do a different color? I'll do red.
Aw.
Blue?
Green.
Green? All right. I won't put too many drops in because I don't want it to be too dark. Oh, I bet that's... Well, we'll see if that's easier to see or not. Let us know in the comments if you can see it. Here we go. This is a big paper clip. Too much.
Someone said if you have the right coins, they float too.
Coins? I've never tried to float a coin before.
So the Japanese yen will float.
That is cool. The Japanese yen will float. I've never tried that. So I'm going to use the small one again. I couldn't... Oh, here's another way to do this if you have a hard time. Come here, little paper clip. No! I have one more. But what you can do also, I wanted to show this to you. You can take a piece of tissue paper. I've had some success with this, not always. But you can take a piece of tissue paper and lay it on the top. And then lay your paper clip on top of that. And then what you can do is gently push away. And it would work. There we go. So there's another way. There's another way to get your paper clip to float, is using the tissue, which has a lot of surface tension there and it floats, and then lay it on top and then move the tissue out of the way. And once again, the best part about this is, oh, it's a little floating paper clip. Hello, little paper clip. How are you today? Would you like to go to the bottom of the cup? 9. Too bad. All right. Oh, that one went fast. That was cool. So there is a really cool little experiment that you can do here. I've got a penny, and we're going to try to zoom in on this. And I have a new penny also. And my question is, how many drops of water can we get on our penny? So we're going to do that now. And I'm going to challenge all of you to try this at home. Now, you might not have a little pipette or like a little plastic syringe or anything like that, but you could try it with a straw. You could grab water with a straw and hold it, cap it, and then drop it on. But the idea is, how much water can we get on this penny? So I'm going to drop little drops. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Can we see that at all? Or is that too small?
I think it's too small.
15, 16. I got an idea.
You could take the caterpillar plant can.
17, 18, 19, 20, 21. How's that?
I think that'll work. Yeah.
Perfect. Teamwork. All right, here we go. Does anybody know what president that is on our penny? Leave it in the comments. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I knocked that off. That wasn't even fair. 14, 15, 16, 17, 18, 19. Okay, it's rolling off. That was my fault. We're going to do that again. I didn't not... That was like a magic trick. I just made it disappear. All right, here we go. If at first you don't succeed, try again. Third time is the charm. I'm going to take my time. 1, 2, 3, 4, 5. Count with me. Oh, it keeps rolling off the side. Ah. I'm going to get a new penny. I need a new cup. All right, fourth time is the charm. If you're still there, hanging in there with us, thank you. 1. The other one had almost 20. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, did you see? It's filling up the coin. And look, it's now... That was 14. But you can, it's like you can see them better. 14, 15, 16, 17, 18, 19, 20, 21. It's still on there. 22. Oh, I think
it's still there.
23. There it goes. So 22, 23, put it over the top. 23 drops on a penny. What about a dime? What about a nickel? What about a quarter? What about a silver dollar? What about a half dollar? Give it a try. I think that's pretty cool. So it's staying on top of it because of surface tension, but eventually what happens is you have so much water and it's starting to kind of bubble out, and it's not strong enough to hold it anymore, and then it breaks and it kind of flows over the side. Had it earlier, we had our soap, and it caused the pepper, paprika, and oregano to move away from it. So I wonder if we had like a little boat, and I put the boat here in the corner, and then what I try to do is if we put the soap here to break the surface tension, I wonder what'll happen. All right, let's get our Q-tip ready again. Are we ready, Mrs. C?
Yep.
All right, here we go. Boom! Oh, that's so cool. All right, let's see if we can get a second one. We got one earlier. Boom. Oh, look at it go. That's so cool. I wonder how far you could get it to go, like if you did this in the tub. So it's still going a little bit. And now that it's basically done. All right. Try that. That's super cool. I wonder how far you could get it to go. All right, so we have a plate. So milk has a lot of water in it, and it also has fats and proteins. So we're just going to add a little bit of milk. And then we're going to take some food coloring. And just so everybody, this is 2% milk. 2% milk. I'm going to take some food coloring. I'm going to drop it in the center. Center-ish. All right. Once again, we have our Q-tip. There's nothing on it. And now what we're going to do is we're going to put a little bit of soap. See if it changes anything. How cool is that? So, this shows us what's happening in the milk. We can't see it because it's all the same color, but the food coloring allows us. Did you see that drop? I dropped a piece of soap on it and it went crazy. It's still going. So what's happening is soap is really cool because, oh my gosh, it just keeps going. Look at that. It's like spewing from the center. That was amazing. I've never had to do that. And oh my gosh, look, it just keeps going every time I drop more soap in it. So it's still reacting. So this is a little bit different. It has proteins in it and fats. And what happens is the soap is grabbing, it's grabbing onto the fats. And once it has that fat, there's another end of the soap molecule that grabs water. And so basically you have this dance and all of these things are grabbing each other and moving and chasing each other. And that's how when you wash your hands are greasy. The soap helps get the grease off because it's grabbing the grease, but it also grabs the water at the same time. So it can handle both of those, and then it gets rid of the oils for you that are on your hand, the grease. All right, let's try that again.
What can they do if they only have gel food coloring?
If you have gel food coloring,
Could you just mix it with water to make it?
is that Lily and Piper?
Yeah.
Yeah, I remember you guys asked about the gel food coloring last time. Try mixing the gel food coloring into water, like dilute it, and then use that to try the experiment. And my question is would the gel work? I've never tried it with gel, but would it work? But if it doesn't work, ooh, look at that plate, by the way. That looks so cool. Science art.
Ooh.
That looks awesome. All right, here we go. Let's try it again. So we've got our plate. But yeah, I think the gel food coloring could work if you dilute it. There's only one way to find out, people. And that's to have my little scientists all over the place trying these things. All right, here we go. And Lily and Piper, I know you got it. You got this. You got it. I'm gonna move the color different places now. 5. All right, so right now it's not moving. I'm the milk whisperer. We should have counted to 5 in like 4 different languages. I could have done 2, 3 maybe. All right, here we go. So we've got our colors. That is so cool. Milky fireworks. Look at that. You can see how the milk is moving.
It's so different this time.
It's completely different. They're both moving out like it's creating a big circle, but that first initial burst.
We have friends that are trying it right now.
Take photos and videos and pictures, please. We want to see you guys doing your experiments.
And a friend who's going to try whole fat milk.
That was my next thing. Okay, so this is 2%. Here's the challenge. We need someone to test this with 1% milk. We need someone to test it with skim milk. We need someone to test it with whole milk because the soap is reacting to the different amount of fat. So I wonder what'll happen. I'm going to just try to load another piece of soap and see what it does, if it does anything. Yeah, so this one's almost done. I would say this one's pretty much done. What was that? Oh my gosh. You guys can't see that. I'm going to get the other cam.
Okay.
I don't know if you guys could see it. When I flicked it, do you guys see the little bubbles? Can you see the little bubbles floating across it? Can you see that? I just flicked it and I saw these little bubbles. They're like teeny tiny bubbles scooting across the water, well, the milk. Oh, it's like the splash is creating a bubble, and then the surface tension is allowing it to glide across. Oh my goodness. I have never, I was just flicking it and I didn't even notice it. Look at that. I don't know what that's called. Or what that is exactly, if that's called anything. That is super cool. All right. I'm just having fun now. I'm sorry. Or put that back. We'll put this back. Look at that. It looks like a face. Oh, I love science, it says.